All right, this is part of chapter 19. We have all these carboxylic acid derivatives. One of those derivatives is an ester, and you know that your ester has the functional group RC double bond OR. This carbon is sp2 hybridized. This oxygen is sp2 hybridized. This oxygen is sp3 hybridized. So when we get to naming esters of this functional group, we have the alkyl part, which is bonded to the sp3 hybridized oxygen. And we have the alkanate part, so that will include the C double bond and the O. It is given the alkanoate nomenclature. So when we name an ester, the ester will be your alkyl part, followed by a space, and then you will have your alkanoate. Part. Okay, so in the alkanoate portion, your alkanoate is determined by the longest chain starting from the carbonyl carbon. So the alkanoate portion starts at the carbonyl carbon, and when we name these esters, if I use a simplistic example and we look at this molecule, that molecule, let's identify the alkyl part and the alkanoate part. So our first name, this is 2 carbons. 2 carbons is a ethane. So it has the ill, so ethyl would be the front portion of the name. And now The alkanoate portion would be 1, 2, 3. So this is a propane. We have 3 carbons. I scratch out the E and put OATE. So the correct name for this is ethyl propanoate. Ethyl propanoate. If we look at another example, so my alkyl portion is the portion attached to the sp3 hybridized carbon. My alkanate portion is the portion attached to the C double bond and carbon oxygen. So let's count the alkyl part. We have 1, 2, 3. So 3 carbons is a propane. So that propane becomes propyl. Okay. And the alkanoate portion, 1, 2, that would be ethane, would be. So I have to scratch out the E and add OATE, ethanoate. So this would be propyl space ethano. Ethanoate. Okay. Now let's look at some substituents. Let's say substituents. On the alkanoate and alkyl part. So, of course, we can add substituents to the alkanoate part and the alkyl part of the ester. Those substituents have to be included in the name. So, for example, this molecule so on the alkanoate portion, I have 1, 2, 3, 4. Okay, so that it would be a butane, this would be butanoate, last name. Now, since this methyl substituent here is on the alkanoate portion, I have to include that with the alkanoate. So I have to say 2-methyl butanoate. Okay, so that takes care of that portion here. Now I want to take care of that substituent coming off of the sp3 hybridized carbon. That, of course, is a methyl. So I would name this methyl 2-methyl butanoate. So to rewrite that, we would say methyl space 2-methyl butanoate. Okay, so there is a space in between your alkyl and your alkanate portion with respect to naming. Alright, let's look at another example. Okay, so we have oxygen as a substituent. Okay, this will follow the carboxylic acid construct. So when we have this double bond O, we want to name it as oxo. So we have 1, 2, 3, 4. This is going to be a butanoate. That's your alkanate portion. And I have a double bond O on number 2. We'll have 2-OXO. Alright, now I need to take care of the first name. I have 1, 2, 3 carbons there. So that's going to be a propyl group. And I have a methyl coming off of number 1. So this is 1-methyl propyl. Okay? So this is going to be the first name. This is going to be the second name. So when I put all of this together, one methyl propyl space 2-oxo butanoate 8. Let's look at another example. Okay, we can start with our first name. 1, 2, 3. So I have 3 carbons attached to that sp3 hybridized oxygen. So the first name is going to be propyl. Okay, that is my alkyl part. This is your alkyl. Okay, the second part is going to be 1, 2, 3, 4, 5. So that's going to be a pentanoate. I have a OH on carbon 2, so that's going to be 2-hydroxy. So the correct name for this is propyl space 2-hydroxy pentano 8. So we deal with the OH in the same construct where this carbonyl carbon takes precedence with respect to naming. Let's try another one. Okay, we can go for the first name first. No matter what side I draw it on, left, right, up, down, you should recognize your alkyl portion and your alkanoate portion. So this is your alkyl portion. This is 1, 2, 3, 4. 4 carbons would be a butane. Alkyl name would be butyl. What do I have on that butyl group? I have 1, 2. 1, 2 dimethyl. Okay, so that's 1, 2. Dimethyl butyl. Okay, let's deal with the alkanoate portion. So I start my numbering at the carbonyl carbon coming off of the sp3 hybridized oxygen. So this is going to be 1, 2, 3, 4. I have 4 carbons again. So this is going to be a butanoate. And what do I have? I have a oxo coming off of 3. And I have a chloro coming off of 4. In alphabetical order, I have to put C before O. So this would be 4-chloro -3 oxo butanoate. Okay. Let's try a couple of more. Okay, let's look at the alkyl portion. This is a branched substituent. This is a branched or complex substituent. So my longest chain in this carbon substituent is going to be 2. So my longest chain is an ethyl. So ETHYL. And coming off of 1 and 1, I have these two groups. So this is 1, 1 dimethyl ethyl. Okay, so this takes care of my alkyl portion. Now, on this other side, this will be carbon 1, 2, 3, 4, 5. So I'm going to have a pentanoate okay, coming off of carbon 2 is chloro, so I'm going to have 2 chloro. Coming off of carbon 3 is oxo pentanoate. That's my last name. My first name is going to be 1, 1 dimethyl ethyl, and a space in between the L and the C. Alright, let's look at one more example, a couple more examples. Alright, so the alkyl portion my longest chain consists of 1, 2, and ethyl. On number 1 I have the amino, 1 amino ethyl. Okay, on my alkanoate side, I have a, let's see, this is 1, 2, 3. So on number 3, I have, this is a cyclopentyl, cyclopropyl, excuse me, cyclopropyl, and also on 3 I have a oxo. So the correct name for this is 1 amino 3 cyclopropyl dash 3 oxo 1, 2, 3 carbons propanoate. Let's look at one that contains a double bond, degree of unsaturation. Okay, so alkyl portion here, that's just simply a methyl group. Alright, so now the alkanoate portion, we're going to have 1, 2, 3, 4. So it's going to be would be a butanoate. But because of that double bond between carbons 3 and 4, I have to change it to a E. Okay, and I have a chlorine on carbon 4. So I can name this two different ways. I can say methyl space 4-chloro dash 2 butene butanoate, or I can say methyl 4-chloro but2en OATE. Okay, what about these sp3 hybridized atoms? That contain chiral centers Okay, so if we take care of the R portion, this would be phenyl, and if I put some substituents, let's say an OH here and an OH here, I've now made these two carbons chiral. So it's a phenyl. 1, 2, 3, 4, 5, 6. One, two, three, 4, 5. So it's going to be a pentanoate. Okay, and I have 2 OH groups, so I'm going to have a dihydroxy on which carbons? 3, 4 dihydroxy. Now, I need to assign the absolute configuration for 3 and 4. This is going to be 1. This is going to be carbon, hydrogen, carbon, oxygen. It's going to be 2. This is going to be 3. It's going counterclockwise, so I'm going to have the S configuration for number 3. We look at 4, position 1, position 2, position 3. Again, going counterclockwise, that's going to give me S, that's 4. So the correct notation is phenyl space 3S 4S dash 3, 4 dihydroxy into 8 pentanoate. One more example involving quite a few substituents. Okay, so let's deal with the alkyl portion first. Alkyl portion. Longest chain, 1, 2, 3. So I will have a propyl. Off of that propyl, I have a bromo and a chloro on 2. So this would be 2 bromo, 2 chloro, propyl. Coming off of 1, I have this methyl, so I would have 1 methyl. So to write the R portion, the alkyl portion correctly would be 1 methyl, 2 bromo, 2 chloro, propyl. Okay. Now your alkanoate carbon 1, 2, 3, 4, 5, 6, 7. So we know we're going to have a heptanoate. Okay, let's address the substituents. This one, this one, this one, and this one. So on 2, I have hydroxy. 3, I have amino. 4, I have oxo. And 5, I have cyclobutyl. So to write out the alkanoate portion correctly, I would have 3 amino, 5 cyclobutyl, 2 hydroxy, 4 oxo, and my last name would be heptanoate.